Hi, welcome back. This is Rakesh Naik. Today we are going to discuss about equivalence of finite automata. Before we start, a small information I'd like to share. In this channel, we produce every video in two different languages, Hindi as well as in English. And if you want to watch this video in Hindi, kindly follow the link given in the description. And if you have not yet subscribed, please subscribe and press the bell icon so that you will get regular updates from this channel. So, let us start. Till now we have seen many things in finite automata, like we have seen DFA, NFA, epsilon NFA. Today we are going to see how can we say that two finite automata are same. We can say two finite automata are equivalent if they accept same set of string over same set of input alphabets. You need to remember here the input alphabet in both the automata supposed to be same. If there is a string W defined over the input symbols which is accepted by one finite automata and not accepted by the other one, then these two finite automata are not equivalent. Basically, we apply comparison method to test whether the two finite automata are equivalent or not. So let us see what is comparison method. How generally we compare two finite automatas. Let us say we are having two machines, M1 and M2, and both of them are defined over same input symbol. Then we'll construct a comparison table with n plus 1 columns, where n are the input symbols. If let us say two input symbols are there, then in our table we'll be having 3 columns. But the first column will be written in the form of Q dash, in the form of pair, where Q is one state from first machine and Q dash is the state from the other machine. And if Q dash appear in any row in the first column, the corresponding entry Qi dash in the ith column, where I is the input symbol, where Qi and Qi dash are reachable from Q and Q dash on I transition respectively. It means what? Transition on state Q by given input symbol I am writing it Qi. Similarly, on Q dash, a transition on input symbol I is Qi dash. So let us say I am defining a transition. Then we'll start constructing the comparison table with the initial state of both the machine. Let us say Q0 and Q0 dash are the initial state of machine M and M1 respectively. And for each input symbol, find the corresponding state Qi dash that is reachable from the starting states. And we'll write it in the corresponding column. And we'll construct the comparison table row wise till we reach two cases. The first case is we reach a pair Qj and Qj dash such that Qj is the final state in M and Qj dash is not a final state or a non-final state in the other machine, or it may be other way around. Then we'll terminate constructing and say these two finite automata are not equivalent. And in the second case, we'll keep on adding row after row and we'll check from the second column to the subsequent column. If at all any new state appearing, that state must appear in the first column also. If all the states are there from the second to last column and all the states appeared in the first column itself, we'll stop and we'll say that the finite automata M and M1 are equivalent. When it is going to theory point of view, it may look little bit difficult, but when we do an example, it will be very easy. Let us do an example. Here are two finite automatas given. Let us say this M and let it be M1, and the corresponding transition table are also given. And we are interested in checking whether these two finite automata are equivalent or not. As you have seen in the rules, we have to start with the starting state. In machine M, the starting state is A, and in machine M1, the starting state is Q0. So I'm writing here A and Q0. This is my starting state. Now on these, I have to find the transition on 0 and 1. You can see one thing, in both the machine, maybe the states are different, but their input symbols are same, 0 and 1. So what we have to do? We have to find the transition. So A on 0 goes to A and Q0 on 0 goes to Q0. You can see it means A and Q0 on 0 goes to A and Q0. Similarly, A Q0 on 1. A on 1 goes to B. You can see here. And Q0 on 1 goes to Q1. You can see here. So A Q0 on 1 goes to B Q1. So I'll write both the states here. You can see here the formula. In each Qj, Qj des, if Qj belongs to F and Qj des belongs to F des, or if Qz doesn't belongs to F and Qj des doesn't belongs to F des, then we can continue. Here you can see A and Q0, both of them are final state, and B and Q1, both of them are non-final state. So we'll continue. On the second column, you see A and Q0 already appeared in the first column, so we need not do anything for A Q0, but there is a new state under one column, that is B Q1. So we'll start constructing with the pair B Q1. So let us find B Q1 on 0. So B on 0 goes to C, you can see, and Q1 on 0, Q1 on 0 goes to Q2. So B Q1 on 0 goes to C Q2. Similarly, find the transition B Q1 on 1. B on 1 goes to A, B on 1 goes to A, and Q1 on 1 goes to Q0. Q1 on 1 goes to Q0. So B Q1 on 1 goes to A Q0. So we can fill the entry on the table. Again we'll check the same thing. If both of them belongs to final state or both of them doesn't belongs to final state. You can see C is a non-final state, Q2 is a non-final state. Similarly, A is a final state, Q0 is a final state. So either both of them belongs to final state or non-final state. So we'll continue. You can see here BQ1 is over. In the second row there is a new state CQ2. AQ0 already appeared. So we'll start constructing for CQ2. So CQ2 on 0. C on 0 goes to B. Yes. And Q2 on 0 goes to Q3. You can verify from here. So you can write CQ2 on 0 goes to B Q3. Similarly, CQ2 on 1. C on 1 goes to C. Q2 on 1 goes to Q2. So we can say CQ2 on 1 goes to CQ2. So we'll write the table. Again we'll check both of them supposed to be in the final state or non-final state. B and Q3 are non-final state. C and Q2, both of them are non-final state. So we'll keep on doing. And here you can see BQ3 is a new state appeared. So we'll find BQ3 on 0. B on 0 goes to C. Q3 on 0 goes to Q2. So I can write BQ3 on 0 goes to CQ2. BQ3 on 1. So B on 1 goes to A and Q3 on 1 goes to Q0. So BQ3 on 1 goes to AQ0. So write it in the table. Again you check whether both of them are final state and non-final state. Both C and Q2 are non-final state and both A and Q0 are final state. And you can see here, whatever state appeared here, already we got all those things here. AQ0 already there, BQ1 already here, CQ2 already here, and BQ3 already here. There is no new state here. It means we have already reached to the place where we can compare. So you can see for all the states, the pair are either final states or both of them are in non-final states. So we can say that both the finite automata are equivalent. Let us take one more problem. We are going to compare these two finite automata. So the starting state is A and Q4. We'll start find the transition on 0 and 1. So we'll start with A and Q4. Both of them are starting state of the respective finite automata. So A Q4 on 0. So AQ4 on 0 will be going to AQ4. We need to find AQ4 on 1. So A on 1 goes to B and Q4 on 1 goes to Q5. So AQ4 on 1 goes to BQ5. We'll write these two here. So here you can see A and Q4, both of them are final state, and B and Q5, both of them are non-final state. And the new state that appeared is BQ5. So we'll start finding the row for BQ5. Now BQ5 on 0. B on 0 goes to C and Q5 on 0 goes to Q6. So BQ5 on 0 goes to CQ6. Similarly, BQ5 on 1, it will go to AQ7. Now you can say CQ6. C and Q6 are non-final state and A and B7. A is a final state whereas is a non-final state. So in this pair, one is final state and another is non-final state. So we'll stop here and say these two finite automata are not equivalent. I hope you understood. One problem we did to show equivalence of finite automata. Another problem we did to show the finite automata are not equivalent. I hope you understood it. If you understood, give a like and share among your friends. In our next video, we are going to talk about how to convert NFA to TFA. See you then. Take care. Bye.